Hey folks, today we are going to build the EggNOGS Eggbeater antenna kit from Halibut Electronics. This is going to be a fun kit, so let's get to it. All right, so what are we going to do today? First of all, what is EggNOGS? Simply put, EggNOGS is a kit to build an Eggbeater antenna. So what's so great about this kit? Well, instead of rehashing all the great information that Mark shared with me in a recent interview at Hamvention, I'm going to link that right up here so that you guys can watch that video and get all the details about what EggNOGS is and what it does for you from a kit perspective. Why an Eggbeater antenna? Eggbeaters are an ideal, simple antenna for working satellites. They have a roughly hemispherical radiation pattern covering the entire sky, without the deep knolls straight up that vertical antennas have. They don't require rotors to keep a directional antenna pointed at the satellite as it moves through the sky. Eggbeaters are commonly used on simple satellite downlink stations like those used on the SatNOGS network. So when you go to purchase your kit, you have to make a decision in terms of what frequency you want to purchase. And that frequency is going to be based on what you want to do with your Eggbeater antenna. Here you can see Mark has options for amateur radio satellites, weather satellites, and commercial satellites. Through the course of the build, you're going to have to make a few decisions. First of all, you need to start thinking about what you're going to use for your aerials. Now, these are wires or parts that you provide yourself. So Mark uses and suggests using some Romex, where you strip out the conductors from that Romex wire and use those individual conductors. I think I'm going to try some electrical fence wire, and we'll see how that works. The good news is it's not difficult to swap these out. So if you use one type of wire and you want to try something else, you can easily do that. One of the other things you need to decide is what type of coax connector you want to have on your antenna. Now, when I purchased my kit, it came with an SMA connector. It sounds like Mark also has options for a BNC and a type F connector, but you can easily provide those yourself if you change your mind. I'm going to go ahead and install the SMA connector in my builds. And then one of the other decisions you need to make is on polarization. Do you want right hand or left hand circular polarization? Now, for me, most amateur radio satellites use right hand circular polarization. So that is what I am going to do. And Mark talks about that in his document. So he says if you're not sure, go with right hand polarization. All right, tools that you're going to need. Very simple. You're going to need some wire cutters, wire strippers, both for 14 gauge and 22 gauge, a soldering iron and solder. Mark does caution that you're going to have a decent soldering iron here. A lightweight soldering iron, something that doesn't get hot enough, may not be able to create a good solder connection for that SMA connection. Or whatever your coax connector happens to be. A number 2 Phillips screwdriver and a 11/32 nut driver or another type of wrench. Okay, here, let me show you the tools I'm going to use in the build. All right, here we've got my scissors to cut the coax. I've got 2 different size wire strippers. I'm going to use the pine sill soldering iron. Here's my number 2 screwdriver, and I'm going to use this little set of channel locks as my wrench to attach the board to the PVC cap. All right, let's see. Next up here, what's provided from a parts perspective? He's got a phasing board, binocular ferrite, a short piece of 316 coax, a zip tie, your cable connector. In my case, I've got the SMA PCB cable or edge mount socket, some stainless steel hardware, and the PVC cap. And we'll take a look at all those items in just a minute. And then, as mentioned before, you have to provide a few things to finish out the build. You're going to have to provide your own aerial loop material. You'll need either some PVC or some other Hamgenuity to actually deploy the deploy the antenna on a mast. Potentially a ground reflector if you so choose to implement one of those. And of course, you're going to need your feed line, your radio, yada, yada, yada. So here's the major points of the assembly. We're going to assemble a common mode choke. We're going to solder the common mode choke to the phasing board. We're going to solder the SMA connector to the phasing board. We're going to connect the phasing board to the main board via solder. We're going to assemble the boards into the cap, and then we'll attach the aerial loops. All right. Well, let's go ahead and take a look at the parts that come in the kit, and we'll get started. All right, so here's what's in the box. We have our little piece of RG316 coax. We've got a zip tie. We've got a bag of hardware, stainless steel hardware, as well as our BNC Edge PCB connector. We've got our PVC cap. Mark throws in a little sticker. Here's our binocular toroid. And we have a couple of boards. This is the phasing board. You can see it's designated with the frequency. There's also some markings here for right-hand polarization and left-hand polarization. Okay. And then here is the main board. And the main board is also labeled this side up and this side down, and that's in relation to the cap placement. So when this gets installed in the cap, this side up is going to look just like that, and our phasing board is going to slip into these holes here, and again this side up and this side down. All right. So to get to the documentation, if you go to the support tab in the Halibut Electronics site, select documentation, it'll bring you to this page here. And here are our instructions. All right, let's get this so we can see more of the guide more easily. There we go. And as I mentioned, this is a great document. There is a lot of information here. I'm going to scroll down here to the assembly section. Okay. Here's a shot of what the assembled boards look like in the end. And we're going to start here with the common mode current choke. Okay, and if we see here, Mark thinks that this is likely the most challenging aspect of the build. So if you get through step one, I think you're in pretty good shape. All right, let's see. Mark's given us a picture of what this should look like if we've done it correctly. So what I'm going to do is I'm going to feed in just a little bit of the coax into this ferrite core. I'm going to put just a little bit of pressure, outward pressure, so I can pull this long edge through. And then I'm going to let that pressure up and push both ends through at the same time. And I think that looks pretty good. I think we'll go with that right there. Okay, let's see. Next up. All right, here's the moment of truth. We've got to actually cut the coax. Gonna grab my scissors here. That looks pretty good. And there we go. Okay, we'll set this aside. Not bad. What do we have next? Strip about 1/4 inch of the outer jacket off both ends. Okay. And we've got a little tip here. I found wire strippers with a circular cutting hole, not the angular ones, right? So you have those angular ones that are adjustable. So those are a no-go. For 14 gauge wire works pretty well. Okay. Carefully close the cutters on the cable, open them, rotate and twist the coax a bit. Close and open again. This will cleanly cut the insulation. Okay. So strip 1/4 inch, 8 millimeters. All right, let's grab the right tool for the job. And this one here has a 14 wire gauge, AWG. So that should do the trick. And let's see, 8 millimeters. I've got a little scale here that I'm marking against. Okay, so I'm going to go right about there. I'm going to find that 14 millimeter slot. I'm going to go up to that 8 millimeter. Let's move that up. Okay. Okay, I think I've got that cut. I'm just going to work that jacket off here. Yeah, it looks good. Okay. First one down. Okay, let's get this one lined up. That looks good. Okay, I think I've got it cut. Just working it slightly. Make sure I do have it cut. I want to preserve as much as that of that shield as I can. Looks like I could stand to cut just a little bit more. There we go. And just one little bit of shield lost there, so not bad. And let me even this back out again. Okay. I'm happy with that. That looks good. All right, let me get these out of the way. And what do we have next here? Rolling straight through the instructions. Yeah, that looks good. I like it. Okay, unwrap the shield from the center dielectric and pull it to one side and twist it so it sticks out 90 degrees from the coax. Okay, so we're going to take this here and I'm just going to fan that out from the dielectric. Being careful to make sure I get every single strand of that shield. Okay. Okay, I've got that all pulled to one side. Now I'm going to just twist it. That looks pretty good. Let's do the same over here. Being careful to get all the strands, but also make sure you're not breaking any of the strands off of that shield. Right, this is where you learn if you did a good job stripping or not. Okay, let's push all that over. I'm kind of digging my fingernails into that jacket so I can make sure I spread this out well. That looks pretty good. It doesn't look as good as the other side. This is where being a little bit of a perfectionist can make you crazy. Let's see here. Okay, that looks pretty good. I need to just get over it and make that work. Okay. Okay. So there we got both of those kind of pointing skyward. Okay. We'll do that. Let's see what we've got next. Cut the dielectric about 1.6 millimeters, the depth of the PCB. Okay. Let's see what we've got here. You know, I've got one leg just a little longer than the other. I'm going to trim that. There, I like that better. Okay. The width. Yeah, how about that? Okay. So we need our other set of crimper or wire strippers. Okay. And this one is 20 to 22. I'm going to go with 20 just so it's a little bit larger. And let's see how this goes. Okay. And there we go. That looks pretty good. And we'll do the same here. Okay, excellent. I'm happy with that. Okay, I'll even these out just a little bit. Good. All right, let's move on. Okay, that's what we got. That's what it looks like. Happy with that. Lots of pictures here, which is great. Okay, now let's grab our phasing board. And we've got more pictures here on the board, so that's great. So we can see this is going to mate into the board as such. Okay, we're going to solder the shield to the large pads on the side with the square, and then we'll bend over the center conductor and solder it there. Okay, that makes sense. Let's see. Let's see if there's any hints on. There should be about 3/8 to a 1/2 inch of exposed coax between the board and the core. Okay. I've got maybe a little bit more than that. I'm just seeing what this is going to look like bent over. Yeah, but you know what? I'm okay with that. I don't have a problem with that. Let's see. Okay, that looks good. While holding the coax as close and tight to the board as possible. On the other side, bend the center conductor over. Okay, solder these two center pins. That should hold it in place. Okay. And then we come back and we solder the shield. All right, very good. So let me get the wire strippers out of the way. Let me get some of these little bits out of the way so we got a nice clean surface. Okay. That looks good there. Boy, I almost want to zip tie this beforehand. That feels like it might be just a little long. I don't think that's going to matter though. And you know what? I am going to try that. I've got another zip tie if I need it. Let me zoom ahead here and see the recommendation for the zip tie. You know, I could shorten this just a tad. All right, I'll do that. All right, just so that's, let's see, which one of these don't I like as well? I don't like this one as well. So I'm going to go ahead and I'm going to snip this. I'm going to do it again. So maybe dry fitting that beforehand would have been smart. Just to make sure your coax length is good. I'm gonna, again, just put some pressure against this side as I push. Well, yeah, it's slippery. Okay. Guess I can just pull that through. There we go. Let's see how that's going to look. If I dry fit that on the board. Oh, I feel like I could still. How's that look? Yeah. I'm going to shorten that up a tad. Let's try. Hold some pressure there. This guy's a little bit of a struggle. There we go. How's that look? I think that's the ticket right there. Okay. Let's get the strippers going again. That looks good. Pull that jacket off. Okay. Let's go ahead and nudge the shield back away from the dielectric. Good. Let's spin that. So we'll want something good to solder. Here's a couple of tails. We'll move those back over to this side. Okay, good. Now let me get my other strippers. Okay, good. Okay, let's even up these legs. And now let's see how this fits. compare it to Mark's picture there. Yeah, I think that looks pretty good. All right. All right, let's get the soldering iron fired up. I'm using the pine cell, so I'm going to power it with this Anchor PD power source. Okay, I've got that over and out of the way. All right, let's see. I don't think I quite need to be that hot. I may for the SMA connector, but not for this. All right, let me grab my helping hands. All right, let's get everything fit into the frame here. Let's see, the first thing I'm going to do is I'm just going to see if I can get this where you guys can see it as well. This may or may not work for you guys. Yeah, we're getting there. The first thing I'm going to do, I'm just going to tin these leads, these shields. Here, let's add a little light, that might help. Okay. Let's add a little flux. Okay. Just adding a little flux here. As you guys know, this will make the solder flow so much better. Okay. And let's see what we've got here. Let's get a little bit of little solder on my iron. And let's just tin those up real quick. Okay, that looks good. I'm going to do the same right here. Okay, we'll get just a little bit of flux on that center conductor. That's a braided conductor, if you can't tell. And again, I'm just going to add a little bit of solder to my iron. And quickly touch it. And that'll give me a little bit better surface to solder with to the board. Okay, I'm happy with that. Now let's go ahead and tin the board just a little bit here as well. All right, anything we can do to make the process easier is good. Putting just a little bit of flux here. This applicator is nice from a precision standpoint. Okay. Okay, that looks good. I'm going to go ahead and flip this over. And I'm going to do the same thing here. All right. Get these pads tinned up. Want that to be nice and shiny. Okay. Now, let's see, we're going to put that through. All right, so I'm going to bend these over. Yeah, we'll do that once we get them in. Okay, so let's put that through. Remember, I got to keep the leads, the shields, toward the shields, obviously, but you don't want to tack this on the wrong way. Okay, now I'm gonna bend these over. Just using the tip of my flux to kind of make sure that's in position. Dab a little bit of flux on there while I'm here. second to cool. Okay. And we're attached. Excellent. Now I'm gonna push this, holding this onto that tab, starting to bend everything back. Okay, good. Okay, that looks good there. Let's see if I can get this centered up so you guys can see. I know this is a little difficult to see, but we're going to see if we can't get this. Okay. Not happy with that solder joint. Let me get a little more on there and push that in. Okay, just holding that for a second, and then we can inspect it. All right, doesn't look pretty, but I think it will do. Okay, very good. Now, let's see. I'll go ahead and move this out of the way. Okay. Now Mark shows this wrapped around that center. There's some indentations there. Then he shows the ratchet portion. Let's see, the ratchet portion. Let's flip that around. The ratchet portion here kind of right alongside. Okay, I'm trying to pull that tight there to give that some strain relief. I think that's likely it. Oh no, I can get a little more out of that there. I put some pressure on the bottom here. And then, tell you what, let me just grab pressure there. That's probably fine. Yeah, I think that's fine. I don't want it wiggling around though. That's the only thing. There, I got a couple more clicks out of it. And that feels just a bit more stable. All right. I'm just going to step away for a moment, and I'm going to hit this with my bench meter, which I can't get over here at my station position, just to make sure I don't have any continuity issues. I want continuity between these shields, and I want continuity between the center pins, but I don't want continuity between the shield and the center pin. So hold please. Okay, we're back. Everything checks out. I'm going to go ahead and just snip this off. Beauty. Okay, so Mark says the hard part's done. So, hey, we're on our way. Okay, let's see what else we've got here. All right, let's see. That looks good. Okay, SMA or BNC. All right, so this is another solder opportunity here. And so a couple of notes, a lot of thermal mass. You're going to need some heat here. So that's why I'm going to pump up the pine sill. Let's see. Let's go ahead and do that now. I'm going to put that baby on 450 Celsius. We'll see how that does. Okay, and let's see. Yeah, everything's going to be really hot. So you got to let this cool down. Good advice. Good advice. All right. And then here we can see how this is going to get connected. Now, I read this before, and I'm pretty sure Mark said do the center pin first and then do the shields. Let's just verify that. Okay, pay attention. Oh, I zoomed ahead a little too far. Okay. Okay. Solder the SMA connector. Solder the center pin first. There we go. Make sure the center pin is over the center pin pad. Okay, it's easy to reflow. Okay, if you need to reposition, once you're happy, hit all the shields. Okay. So let me try to get this back into position. Okay. Move that out of the way. Okay, that looks good there. I'm going to go ahead and get some flux on this center pin. We'll go ahead and get a little solder there. Okay, a little pad of solder. Let me fish out this SMA connector. Okay, that's where that guy's going to go. Let me get just a little flux. On the center pin. Let's see here. Let's clean this up just a bit. Okay, good. of solder on my iron. Okay. There we go. That looks pretty good. Let me go ahead and get some flux. On these other pads. Get a little bit of heat there. Okay, let me get just a little bit more. Just trying to get some heat on this connector. There we go. Okay. Let's go ahead and flip this guy over. Okay. And let's do the same thing here. Some flux on this nice big pad. I'm just sitting here on this connector until I see a little bit of smoke from the flux that I added. When I see that, it's probably hot enough. This would be nice if I had like a chisel tip or something I could get more contact, but I think I can get a good solder joint here. Trying to get as much of that solder tip on that connector as I can. Okay. Okay. I think that looks pretty good. I like the way that that's designed with that great big pad. Makes it pretty easy. There, you guys can see that fairly well. Let's see if I can get a little bit better view. So that looks pretty good. Boy, that's a tight little space there. I'm going to go ahead and check this for continuity. Make sure I'm not grounding that center pin. Hold, please. Okay. Checked out just fine. It's good and solid. I don't think that's going anywhere. I'm happy with that. Okay, let's see what our next step is. All right, the main board. Okay, we're going to do right hand polarization. So what that means is we're going to take the right hand circular polarization and we're going to make sure that lines up with the polarization selection. So you see how you got that little box right there? We've got right hand circular polarization here. That is how we're going to solder this. Okay. Let's see what we've got. This side up, this side down. Yep, got to pay attention to that. Okay, now Mark suggests just tacking a single pad here. So we're going to give that a try. That way we can make adjustments as needed. Try to move this up. Okay. Let's see this side up. There's our select polarization. My right hand polarization's here. So that's how we're going to do it. Okay. I'm just going to let that kind of balance there. Okay, I'm going to add just a little bit. All right, I'm going to turn down this solder iron just a tad. Let's see. I'm going to get her back into the 360 range. Clean this up just a bit. Okay, that looks good. And we've got one pad. Okay. And we'll see how it looks. That looks pretty good. I'm happy with that. So just a little trick or a little hint on how I did that. I just put that SMA connector directly on my pad, and I let you guys saw how I let the main board just kind of balance on the other board, and that worked out just fine. All right, I'm going to go ahead and going to add a little bit of flux, and we're going to get these guys soldered. Okay. Turn that around. Let me get myself a little more. A little more solder. Okay. That looks pretty good. I'm happy with that. And I'm going to put a little more solder on this guy here. Just going to touch up a couple of these joints since I know that's what's holding these two boards together. Okay. Now we're going to flip this up. This might be difficult for you guys to see, but I'm going to do the same thing here. Okay. All right, let's take a look and see how we did here. Okay, I think that'll do. I want to get a little extra solder on a couple of these pads. Okay, I think that's good. All right, excellent. Let's see what's up next. Structural assembly. Excellent. All right, let me move some stuff out of the way for a second, and I'll be right back. All right, let's see here. I've got my parts situated here, and we're just going to walk through the instruction and make sure we get these installed correctly. And Mark does give you step-by-step instructions, which is really nice. Okay, all hardware stainless steel. All 4 screws are the same. Start with a screw. You go with a split washer. A normal nut. Here, let's go a little bit further. Okay. So we got our locking washer underneath. Okay, we'll go ahead and get all 4 of those staged. Or the 3 remaining staged. Okay. Just hand tightening these for now. Okay, very good. Now these go into the cap. Nice job. Look at that. They actually fit pretty well. That's pretty impressive. Okay, lots of opportunity for that to get misaligned. So I'm going to just get a little bit of, gonna add just a little bit of tightening here. Okay, let's see how these washers look. Not quite flattened out, so I'm going to give them just another Another turn, that looks better. We'll tighten this just so the washers flatten out. Okay. That looks pretty good. Should be more than tight enough. Let's go ahead and get that back in there. Very good. Okay. And then let's see. Next up, we have these caps, these little rubber washers. So here, let me show you guys that. Make sure you can see that. So it's a washer with a little bit of a rubber gasket on there. That's a tight fit. I guess that makes sense. That's what you want. Now you want to make sure you're not pushing on this board. So I'm going to put my fingers up and push against the main board and not the phasing board. We'll get all these started. Okay. And then looks like we're going to have a nut, a washer, and then a lock washer. I'm just going to hand tighten these down to the cap. So you can tell Mark's put some thought into this, which I really appreciate. Feel like I missed, let's see. Feel like I missed a washer. Oh, I see. He's got two washers there. Okay. I'll make sure I'm not getting ahead of myself. Let's just look at the instruction here real quick. When in doubt, look at the instructions. Okay. Oh, the kit includes 4 extra normal nuts. That's what caught me off guard. I forgot about that. So these are our extra normal nuts that we can use in the process. But whenever we're finished, we'll finish it off with these locking washers, right? They got a little nylon insert in there, and they're like a one-time use only. So again, a lot of thought put into this, and that's great. So let's see. So you'll have the rubber sealing washer, a nut, a flat washer, the aerial loop, another flat washer, and the nylon locking nut. So you'll put your aerial loop in between the washers. Come on back here. Get this back on screen. All right, so you get a little bit of space there. Right, and you'll put your your aerial wire, whatever that may be. However you want to do that, either wrap it around that post, or maybe you're going to use a ring terminal to do that, but you've got space to do that, which is nice. I'm just going to kind of hand tighten these down so I don't lose any of those washers. Come here, you little bugger. Okay. And then we'll replace these with the locking washers once we feel good about it. Bam, boy, that feels solid, sturdy, nice. I am pretty happy with that. That is pretty sweet. All right, and I think that is it. And besides the aerial install, you can see in the instructions here, you get the step-by-step. Yeah, and here you can see some good advice here. Compress the split washer all the way. Don't crack it down where you're going to break something, but just get it flat. Then it's not going anywhere. Okay, so it tells you everything you need to know in order to be successful with this. Let's see, while building and tuning the antenna, use the last 4 normal non-lockers. Yep. So he's got a couple of points in there. Oh, sorry about that. Slow that down a little bit. Great pictures in here, right? So you're not guessing, you know exactly what's going on. And you can see here in this case, here, these are those Romex wires. You can see the white and black. Anybody that's worked with Romex, you'll recognize that. And then he just kind of wraps it around those posts, and you can see he's got the locking washers on here. So, all right, congratulations. You've built the hard part. So the next part's going to be adding the aerials, and I am going to do that on a separate video. All right, let me switch back here. All right, so that's where I'm going to end this video. We've got the board connected to the main board, connected to the phasing unit. We've got the ferrite core in place. We've got the BNC the SMA connector soldered in, and we're attached to the cap. So we're ready for some aerials, but we'll save that for another video. So I hope you guys enjoyed this build. Thanks for walking along this project with me, and make sure you like and subscribe if this is something you're really into. Certainly make sure you subscribe if you want to see the rest of this series, which will include adding the aerials and getting these antennas on the air. That will be the exciting part. So until then, though, thanks for watching, and 7-3.